Today we are going to be looking at slopes and using them to find out whether lines are parallel or perpendicular today. So what I want to do is I want to create multiple of the same page, but what I should probably do first is first put the axis on and then create 5 duplicates of the same page, because there's 5 problems. So we want to duplicate 5 graphs. Okay, so now that we have 5 pages, we're going to go back to page 1 and address our first problem, which says if points -3, -2, and -1, 2 are on the line, then the slope of the line is. So let's start by graphing these points. We can either graph them by hand, which is a little more tedious, especially using Geometer Sketchpad, or we can plot the points using the graph function. I'm going to plot the points using the graph function. So you type in -3 and then -2 and hit enter, and it'll plot the first point. And then you hit -1, 2 for the second one, and that will plot that point. So now you're done. So now we want to find the line between these 2 points. So I used the line segment for the line and created a line from that. So in order to find the measurement of these 2 coordinates, which we already knew, all I did was go to measure. Well, I clicked on both of the points and then I went to measure, and then I had it measure both of the points. So we know our slope, and the way that you typically do this is calculate. We know our slope is y2 minus y1 over x2 minus x1. So this is a positive slope. This is our y1 our x1 y1. This is our x2 y2. So we're going to do 2 minus parenthesis -2 parenthesis, which gives us 4. And then we're going to calculate -1 minus parenthesis -3 parenthesis. And then what we're going to do is we're going to calculate yet again, and we're going to do our rise over our run, or our y values over our x value. Well, to make sure that this is our slope, another way that you can measure the slope is by, let me exit out of that. Apparently it doesn't want to work quite so well. You can measure just the slope. Oh, there you go. Our slope is 2. So we calculated it out and we used their measurement system, and our slope is 2. Okay, for the second problem, we are given find the slope of the graphed line. Well, the line that is on my graph, I'll graph quickly for you, is 1, 4 and 0, 1. Done. So based on what we did in the previous one, all I'm going to do is the line is already selected and I'm going to measure the slope. Our slope is 3. If you wanted to go and do what I had done with the prior example, you could use A and B and do it the old-fashioned way with the y2 minus y1 over x2 minus x1. Now moving on to problem 3. Problem 3 says, graph a line that contains t, which is 0, 5, and is perpendicular to CD, where C is 3, 2, and D is -2, -1. So all it wants us to do is graph the line. So what I'm going to do is I'm going to plot the points first. So we know T is 0, 5. We know C is 3, 2. And we know D is -2, -1. So what we're going to do is for CD, we're going to connect those 2 points. And so we already have this line highlighted, and then we have our T now highlighted. So what we're going to do is we're going to construct a perpendicular line. This line is perpendicular to this line. Please ignore what I just did. All right, so for problem 4 is slightly different. It wants us to evaluate lines CD and GF and find out if they are parallel, perpendicular, or neither. So CD, we are given, has points -3, 1, 0.3, 3, G is 0.0, -1.67, and then F is 5, 0. So we've got all of these points, so these two connect here, and these two connect here. So we are currently given all of those points, so I'm going to measure their coordinates. So instead of calling it CDGF, we're going to do AB and CD. So for this line, we're going to measure the slope, which is 0.33. And then for this line, we're also going to measure the slope. Oh, well, they're the same. So because they have the same slope, the lines are parallel. They will never cross. Moving on to problem 5, we're evaluating line JI, KI, and HI to find out if they are parallel, perpendicular, or neither. So we are given, again, points to plot, and the points are 0, 3, 0, tab 3, enter, 0, 3, 1, 0, 2, -1, and 0, -2. So every one of these outside points connects to this one center. Well, I wouldn't necessarily call it center, but this one central point. So we're trying to figure out, is this parallel to this? But those two aren't parallel because they intersect. So that doesn't work. Is this parallel to this? That doesn't work either because they intersect as well. So now we're trying to figure out if these lines are perpendicular. So we should probably establish the point measurements first. So measure the coordinates, and then we'll find out what this equation's slope. So slope of, that was bad placement on my part, slope of DA, slope of BD, or DB, and then finally the slope of CD. Well, none of these are obviously parallel. And what does it mean for a slope to be perpendicular? Oh, for a slope to be perpendicular, it's 1 over the slope and you change the sign. So line AD is perpendicular to line CD.